Hi, today I'll be discussing on the topic types of measurement scales. The design of a measurement scale depends on the objective of the research study and the mathematical or statistical calculations that a researcher expects to perform on the data collected using the scales. Here, the objective of the research study may be as simple as classifying the population into various categories, or as complex as making the units under study and comparing them to predict some trends. So different types of measurement scales like nominal scale, ordinal scale, interval scale and ratio scale. So now I will be discussing one by one. First of all, we discuss about the nominal scale. Nominal scale uses numbers or letters so as to identify different objects. The scale helps segregate data into categories that are mutually exclusive and collectively exhaustive. This scale assigns numbers to each of these categories, and these numbers do not stand for any quantitative value. Hence, they cannot be added, subtracted or divided. Say for example, a nominal scale designed to measure the nature of the occupation like public sector, private sector, self-employed, unemployed, others. So in this example, the numbers 1 public sector, 2 private sector, 3 self-employed, 4 unemployed, 5 others only serve as labels to the various categories of employment status. A researcher cannot use those numbers to perform any type of mathematical or statistical operations using these numbers. A nominal scale does not give any relationship between the variables, and the only quantitative measure is the frequency of items appearing under each category. So the number of people in public sector, jobs, etc. like this. One can only calculate the mode for the data collected using a nominal scale. The second important measurement scale is the ordinal scale. An ordinal scale is used to arrange objects according to some particular order. The variables in the ordinal scale can be ranked. For example, if someone says that a person came second in the examination, then we can understand that there was another person who came first and some others were there who were ranked after the student. This type of scale that gives ranks is called an ordinal measurement scale. Ordinal variables can only give us the information regarding relative position of the participants in the observation, but they do not give the information regarding the absolute magnitude of the difference between the first and second position or second and third position, so on. Let us take an example. An ordinal scale used to measure the performance of customers in Andhra Pradesh for various mobile telephone service providers would ask a question like, please rank the following mobile telephone service providers from 1 to 5, with 1 representing the most preferred, and the 5 the least preferred. So we will be giving like this, like Airtel, Jio, BSNL, Reliance, or any other Idea or Vodafone, like that. So we'll be giving the responses, and the respondent will be ranking from 1 to 5. A respondent may rank these players depending on his experience or perception of the individuals. If a respondent ranks Airtel as 1 and Jio as 2, a researcher can know that the respondent prefers Airtel. However, the limitation is that the researcher cannot be sure as to how strong the respondent's liking is for Airtel when compared to Reliance Jio. So third important measurement scale in the types of the measurement scale is the interval scale. Interval scales are similar to ordinal scales to the extent that they also arrange objects in a particular order. However, in an interval scale, the intervals between the points on the scale are equal. This is the scale where there is equal distance between the 2 points on the scale. Say for example, interval scales are like Fahrenheit and Celsius scales used to measure the temperature. In these scales, the difference between the interval is the same. That is, the difference between 40 degree and 60 degree is the same as the difference between 25 degree and 45 degree. So, but the base point, freezing of water, is represented by 32 degree Fahrenheit and 0 degree Celsius. Thus, there is no natural zero or base for these scales. Similarly, what we can do is we can design an interval scale with the points placed at an interval of 1 point. Say for example 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So here the difference between these 2 points is the 1. And we ask the respondent to place the mobile telephone service providers on the scale of 10 to 1. If Airtel is assigned as 8 and Jio as 4, we can say that the value of the difference in preference is 4. But we cannot say that the liking for Airtel or Idea is twice that of BSNL, because we did not define a point of no liking, that is 0. So the only statement we can make about a respondent's preference for Airtel and BSNL is he likes Airtel more than BSNL, but we cannot give a ratio of the liking as there is no base 0. So interval scales are suitable for the calculation of arithmetic mean, standard deviation and correlation coefficient. Another important measurement scale that we use in our research is the ratio scale. Ratio scales have a fixed 0 point and also have equal intervals. Unlike the ordinal scale, the ratio scale allows us for the comparison of two variables measured on the scale. So this is possible because the numbers or units on the scale are equal at all levels of the scale. A very good example of the ratio scale is the distance. For example, not only we can say that the difference between 4 miles and 6 miles is the same as the difference between 6 miles and 8 miles, but we can also say that the 8 miles is twice as long as 4 miles. So in other words, a ratio scale can be defined as a scale that measures in terms of equal intervals and an absolute 0 point of origin exists. The zero is common to a distance scale using yards, meters, etc. Age, height, weight, money scales are other common examples of ratio scales. Since there exists an absolute zero on the ratio scale, the data collected can be subjected to any type of mathematical operation, say addition, subtraction, multiplication and division. These are the four important measurement scales that we use in the research. Most of the times, at the time of the say if you want to work with the data what we have collected at the time of the designing the questionnaire itself, make sure and ensure that you are designing your questionnaire with the proper scales. Now we will discuss what is the criteria for the good measurement. Researchers normally develop their own scales for measuring variables for different attributes, as it is very difficult to find readily available scales. It is in this process of developing scale that researchers have to be very careful, since the scales what they have developed should primarily stand the tests of reliability, validity, sensitivity and so on. So here we will be discussing what is the criteria for good measurement. There are 5 major criteria for analyzing the goodness of measurement, namely reliability, validity, sensitivity, generalizability and relevance. So now I will be discussing reliability. It is considered that if the outcome of a measuring process is reproducible, then the measuring instrument is reliable. Reliable measuring scales provide stable measures at different times under different conditions. For example, if a coffee vending machine gives the same quantity of coffee every time, then it can be concluded that the measurement of the coffee vending machine is reliable. Thus, reliability can be defined as the degree to which the measurement of a particular instrument are free from errors and as a result produce consistent results. In certain situations, poor data collection methods give rise to low reliability. So the quality of the data collected can become poor if the respondents do not understand the questions properly and give irrelevant answers to them. So there are 3 methods that can be used to evaluate the reliability of a measure. They are test, retest reliability, equivalent forms and internal consistency. The second one, test retest reliability. If the result of a research is the same, even when it is conducted for the second or third time, it confirms the repeatability aspect. For example, if 40% of a sample say that they do not watch movies, and when the research is repeated after some times and the result is same again, then the measurement process is said to be reliable. However, there are certain problems regarding the test-retest method of testing the reliability. The first and foremost issue is that it is very difficult to obtain the cooperation and locate all the respondents for a second round of research. Apart from this, the response of these people may have changed on the second time. And sometimes environmental factors may also influence the responses. So third one, equivalent form reliability. Some of the shortcomings of the retest reliability can be overcome in this method. In equivalent form reliability, two measurement scales of a similar nature are to be developed. For example, if the researcher is interested in finding out the perception of the consumers on recent technological advanced products, then he can develop two questionnaires. Each questionnaire contains different questions to measure their perceptions. But both the questionnaires should have an approximately equal number of questions. The two questionnaires can be administered with a time gap of about 2 weeks. So the reliability in this method is tested by measuring the correlation of the scores generated by the two instruments. The major problem with equivalent form reliability is that it is almost impossible to frame two totally equivalent questionnaires. So another one is the internal consistency. Internal consistency of data can be established when the data give the same results, even after some manipulation. For example, after a research result is obtained for a particular study, the result can be split into two parts and the result of one part can be tested again. The result of the other. If they are consistent, then the measure is said to be reliable. The problem with the internal consistency is that reliability of this method is completely dependent on the way the data are divided or manipulated. So sometimes it happens that different splits give different results. So to overcome such a problem with the split halves, many researchers adopt a technique called as Cron-Batch alpha that needs the scale items to be equal intervals. In case of difficulty in obtaining the data at equal intervals of time, then an alternative method called Kuder-Richardson formula 20 is used to calculate how consistent subject responses are among the questions on an instrument. Items on the instrument must be dichotomously scored, 0 for incorrect and 1 for correct. All items are compared with each other rather than half of the items with the other half of the items. It can be shown mathematically that Kuder-Richardson reliability coefficient is actually the mean of all split half coefficients. So validity. The ability of a scale or a measuring instrument to measure what is intended to measure can be termed as the validity of the measurement. For example, students may complain about the validity of an examination, stating that it did not measure their understanding of the topic, but only their memorizing ability. Another example may be of a researcher who tries to measure the morale of employees based on their absenteeism alone. In this case too, the validity of the research may be questioned as absenteeism cannot be purely attributed to low morale but also be other conditions like prolonged illness, family reasons and so on. Validity can be measured through several methods like face validity, content validity, criteria related validity and construct validity. So let us discuss what is this face validity. Face validity refers to the collective agreement of the experts and researchers on the validity of the measurement scale. The next one is the content validity. Content validity refers to the adequacy in the selection of relevant variables for measurement. The scale that is selected should have the required number of variables for measurements. Criteria related validity. What is this criteria related validity? Refers to the degree to which a measurement instrument can analyze a variable that is said to have a criteria. If a new measure is developed, one has to ensure that it correlates with other measures of the same construct. So what is this construct validity? Construct validity refers to the degree which a measurement instrument represents and logically connects through the underlying theory. Construct validity, although it is not directly addressed by the researcher, is extremely important in the assesses the underlying aspects relating to behavior. It measures why a person behaved in a certain way rather than how he has behaved. For example, whether particular product was purchased by a customer is not the consideration, but why the customer not purchase the product is taken into account to judge construct validity. This helps to remove any extraneous factors that may lead to incorrect research conclusions. There are two statistical methods for analyzing construct validity: convergent validity and discriminant validity. Convergent validity is the extent of the correlation among the different measures that are intended to measure the same concept or content. Discriminant validity denotes the lack of or low correlation among the constructs that are supposed to be different. Consider a multi-item scale that is being developed to measure the tendency of to stay in a low-cost hotel. This tendency has 4 personality variables: high level of self-confidence, low need for status, low need for distinctiveness, and high level of adaptability. Additionally, this tendency to stay in a low-cost hotel is not related to brand loyalty or high-level aggressiveness. The scale can be said to have a construct if it correlates highly with other measures of tendency to stay in a low-cost hotel, such as reported hotels patronized and social class, has a low correlation with the unrelated constructs of the brand loyalty and a high level of aggressiveness. We will be discussing the next one is the sensitivity. What is this sensitivity? Sensitivity refers to an instrument's ability to accurately measure variability in stimuli or responses. Sensitivity is not a high-end instruments involving agree or disagree type of response. When there is a need to be more sensitive to subtle the changes, the instrument is already altered appropriately. For example, strongly agree, mildly disagree, strongly disagree, none of the above are categories whose inclusion increases the scale's sensitivity. Generalizability. It refers to the amount of flexibility in interpreting the data in different research designs. The generalizability of a multiple item scale can be analyzed by its ability to collect data from a wide variety of respondents and with a reasonable flexibility to interpret such data. So we'll be discussing relevance. What is this relevance? Relevance, as the name itself suggests, refers to the appropriateness of using a particular scale of measuring a variable. It can be represented as relevance is equals to reliability into validity. If correlation coefficient is used to analyze both reliability and validity, then the scale can have relevance from 0 to 1, where 0 is the low or no relevance level to 1, which is the high relevance level. If either of reliability or validity is low, then the scale will have little relevance. So we have discussed different types of scales to measure. Now I'll be discussing on the measurement problems. So where do we get all the measurement problems, and we'll be discussing on the different sources of measurement problems, because when conducting a study, a researcher has to analyze the accuracy of the information that has been obtained. Several types of research errors can come in during a study. So what are all the major research errors at the time of measuring the measurement? So that I will be discussing one by one. The first one is the respondent associated errors. A majority of research studies rely on the information from the respondents. If the researchers are able to obtain the cooperation of respondents and elicit truthful, the researchers are able to obtain the cooperation of respondents from them, where the survey can easily achieve its targets. However, two respondent associated errors arise when researchers do not obtain the information as stated. So these respondent errors are non-response error and response bias. What do you mean by this non-response errors? Non-response errors arise when the survey does not include one or more pieces of information from a unit that has to be part of the study. So the research results will have some bias to the extent that those not responding are different from those who are responding. Response bias. What is this response bias? If the respondent consciously or unconsciously misrepresent the truth, then it amounts to response bias. Sometimes respondents deliberately mislead researchers by giving fake answers so as not to reveal their ignorance or to avoid embarrassment and so on. Instrument associated errors. Instrument associated errors due to poor questionnaire design, improper selection of samples. Suppose a simple thing like lack of adequate space in the questionnaire for registering the answers of the respondent can result in errors of this sort. Another type of the instrument error occurs if the questionnaire is complex or ambiguity with a high ambiguity may result in a lot of confusion among the respondent. If the questions in the questionnaire use complicated words and sentences, they will inadvertently lead to errors due to the misinterpretation of such questions by the respondents. Situational errors. plenty of errors arise due to the situational factors. The respondents may not provide proper responses if a third person is present during the interview, or sometimes the third person might himself participate in the interview process without any invitation, leading to inappropriate response. Other factors such as the location of the interview also play a crucial part. For example, if the researcher is conducting the interviews in a public places, then the respondents may not report as properly as they would if they were interviewed in their homes. If the researcher does not assure the respondent that the data provided will be kept confidential, the respondent may not part with a certain information that may be crucial for the research. Measurement itself as a error source. Another important source of the measurement. The measurement may be a source of error because of some of the common mistakes committed by interviewers. During the process of the interview, the interviewer might encourage or discourage the respondent while giving responses to certain questions through body language and gestures, like smiles to encourage certain responses, forwarding to discourage certain responses, and so on. After the collection of the data, the interviewer might reword or rephrase the responses that may lead to errors, failing to record the full response of the respondent. So inappropriate coding and tabulation and application of irrelevant statistical tools for measurement will also lead to errors. So today we have discussed the types of the measurement variables, different measurement scales we have discussed. Measurement variables. We have discussed how to measure. We have discussed the errors of the measurement. Where do we get the errors? So different sources also we have discussed. So hope at the time of the designing the questionnaire and at the time of the coding and decoding process, you will take utmost care. We have other sources also, like attitude measurement. We have like components of the attitude, cognitive component, different behavioral components is there. But as of now, I think this will be these sources of the errors definitely. The sources of the measurement errors definitely will help your will help your project. Definitely the outcome of the project will be qualitative in nature, right? Thank you.